Okay, yeah, oh no. Sorry about that. Oh. Okay, so this is Jacob Nash Engineering Lessons. This is Unit 1, Lesson 6, and sorry about that. There was a terrible audio that played after the one that is the intro, so sorry about that. Okay, we are now looking at this is part 3 of our parent function videos, and I apologize if I seem a little bit disorganized compared to the last 2 parts, because I made this like quite a while after I did the other ones. So we're doing, this is number 8 now of the list that I had, and it's exponential. Okay, so what's an exponential function? Well, when something increases exponentially, it's like, whoa, hey, like it's like that. It goes crazy. Like, you could say that about the coronavirus cases. Like, if you look on the graph, it goes like, it's like, yeah, nothing. Oh, crazy. And then it went, okay, I don't know why that happened. And then it started simmering down, and then it went, oh, crazy again during the summer. Back to normal, and then crazy during the holidays of 2020, and then the vaccine seems to be doing something these days, but that's not the point. Okay, so this is what it looks like on a graph. I don't have the graph paper right now, sorry about that, but it's never going to really touch the x-axis, and then it goes crazy. That's what it does. So once it starts getting into the positive x, positive y quadrant, it goes crazy. So the domain is going to be negative infinity to positive infinity for this one. And the range is going to be 0 to infinity, not including 0 because it never does touch it. And it never goes below 0, so it's just 0 to infinity. It increases from negative infinity to positive infinity, and it doesn't decrease at all. There's no relative minimum or maximum, and it's continuous and bounded below. Okay, now let's look at our last one, which is logarithm. Oh, I forgot to say, for the exponential, the function is f(x) equals e to the x. So basically, the values, the x, it's kind of like the opposite of the square root one, like whatever, x goes into the exponent instead of the number below the exponent. So that's the difference. Now we have logarithm. So logarithm. Ooh, not a very good eye. Sorry about that. Okay, so logarithm is kind of it looks pretty much like it might be the opposite, or basically just like the exponential one if it was turned a different way. The function is f(x) equals ln of x. So ln, you've probably seen that on your calculator. You don't need to use log. That's not what one you use, even though you might think that because it has that. You use the ln one for that. This isn't a very common one, but sometimes that's something that there is. So basically for this one, it kind of just starts out right here. It never touches the y-axis. And then once it gets into this quadrant, it goes crazy and goes like that. That's basically what happens. So the domain would be 0 to positive infinity, because it never touches 0 and it never goes over to this point. And the range is going to be negative infinity to positive infinity. So if you see the domain and range just switched from the exponential one. It increases from 0 to infinity. It doesn't decrease. There's no relative minimum or maximum. It's continuous. And yeah, that would be it. So that's it for this lesson. Thanks for watching, and I'll see you on the next video on order of operations of functions.